In this video, we're going to be talking about solving systems of equations by using the substitution method. The substitution method is used to solve systems of linear equations algebraically. One equation must be solved for a variable, either x or y, doesn't matter which one. That equation is then used to substitute into the other equation. So here we have the steps for solving a system of equations using the substitution method. I'm going to work through each of these steps in our examples today, and they're going to make more sense. But the important thing to look out for is a variable must be isolated. That means it needs to be by itself in at least one of the equations. You're then going to take what that variable equals and plug it into the other equation. Step 3, you're going to solve for that variable that's left, and then you'll take that answer, plug it into one of the original equations, and get the other number, because you have one for x and one for y. And then you'll have one of 3 things happen. When we first learned about solving systems, we knew that they could either have one solution because they intersect, no solutions if they're parallel, or infinite solutions or all real numbers if they're the same line. The same thing can happen for substitution method. If you get an answer for x and y, then that will be your answer. That means that they are intersecting lines. If at any point when you're solving, you get a true statement, so something that looks like 4 equals 4, or 0 equals 0, or negative a million equals negative a million, then your answer is all real numbers because they're the same line. If you get a false statement, like 3 equals 4, or 0 equals 10, or 5 equals negative 5, then you'll have no solution because you'll have parallel lines. I'm going to show you what all of this looks like today in our notes. So, it says solve by using the substitution method, then check your solution, show all work. You always want at least one of your equations to have either y equals or x equals. Lucky for us, in both of these equations, we both have y equals. So we have a variable that's isolated on one side. What you're going to do is you're going to take what y equals in one equation and plug it in for y in the other equation. So because both of these are y equals, I can just plug it in. So I'm going to have negative 2x minus 2 is equal to 0. So what I did was I took what y equals in this equation and I plugged it in for y in this equation. Because both of these equations are y equals, you could have done it the other way around. You could have said y equals 0, I'm going to plug that in for y up here, and had 0 equals negative 2x minus 2. It's the same equation, just switched around. The best way to think about this step is both of these y's, let's use football as an example. Both of these y's are quarterbacks. This is your starting quarterback, and this is your backup quarterback. So, if we're talking about the Patriots, when Mac Jones went down this fall, right, Zappy went in for him. And so we're plugging in Zappy for Mac Jones. They're equal to each other because they're both quarterbacks. Now you could say one's better than the other, but that's a whole other thing. But they both can go in for the same position, right? If you're playing basketball, if you want to do a substitution in basketball, a forward goes out, so another forward comes in. They're playing the same position. They have different names, so they look different, right? They're different people, but they both equal the same position. That's what you're doing here with the substitution method. Now we just have one equation that we can solve. And so now we're just going to focus on solving this one equation. So I want to get negative 2x alone. That means that I need to undo subtraction. To undo subtraction, I'm going to do addition. So I'm going to bring down negative 2x. Negative 2 plus 2 is 0. I'm going to bring down my equal sign. 0 plus 2 is 2. I want to get x alone. X is being multiplied by 2. To undo multiplication, I'll do division. So here, x equals -1. So right now we know that x is -1. So in my answer, I know x. Remember, our answer is always x comma y, so I still need to find what y equals. The good news is they already told us. Right here, they told me that y equals 0. You could, if you weren't sure, take your answer of x equals -1 and plug it in for x and solve. Here I would get 2 minus 2 is 0. But they already told me what y was. They told me that y was 0 right here. So because I know that y is 0, I now have my answer. My answer is -1, 0. The great news about these types of problems is that you can check your work to see if you are correct or not. So on a test or a quiz, you can automatically know if you have all the right answers just by plugging in your work and checking your answers. If you get a true statement for both equations, then you've done everything correctly and you have the correct answer. If you get a false statement in one or both of your equations, then you made a mistake somewhere along the way and you can go back and find your mistake and fix it. Let me show you what I mean. So if my answer is -1, 0, then -1 is x and 0 is y, right? If it helps you, you could write it out like this. So I'm just going to take this right here and plug it into both of these equations. So let's start by checking the first equation, y equals -2x minus 2. Y we said was 0, and x was -1. What I'm trying to do is prove that the left side of the equation equals the right side of the equation. So I'm going to have 0 equals -2 times 1 is 2. 2 minus 2 is 0. I have 0 equals 0. This is a true statement. So the first equation works. Let's look at the second equation. My second equation is y equals 0. Well, we saw that y was 0. Is this a true statement? Does 0 equal 0? Yes, it is a true statement. This means that I have done everything correctly, and this is my solution. So that means that if you were to graph these two equations, they would meet at the point -1, 0. Let's try that again on example 2. Remember, we need at least one of our equations to be either y equals or x equals. Both of these are y equals. So I'm going to take what y equals in this equation, and I'm going to plug it in for y in my second equation. So instead of y equals -2x minus 10, I'm going to have 3x equals -2x minus 10. I'm just taking what this y equals in this equation and plugging it for y in for that equation. Another way of thinking about it is both of these equations are y equals, so these two expressions have to equal each other. From here, I want to solve for solve for x, because I only have x's left. I see that I have x's on both sides of my equation, so I need to get my x's on the same side. To do that, I am going to add 2x to both sides. 3x plus 2x is 5x, and I'm going to bring down my -10. To undo multiplication, I'll do division, and I'll get x equals -2. So right now I know the first part of my answer is -2. I still need to find the y, because I'm looking to see where these two lines cross. Right? If we were to graph these two lines, I need to know the ordered pair where they meet. You can take your answer, and you're going to plug it into either one of these two original equations. It does not matter which equation you pick. Notice how this is different than in example 1. In example 1, they told me that y equals a number. Here I don't have that. So here I have to plug in to find what y equals. Doesn't matter which equation you plug into. I'm going to choose to plug into this first equation because it's going to be less steps. So I'm going to have y equals 3x. So I'm going to have y equals 3 times negative 2 because we got that x was negative 2. 3 times negative 2 is negative 6. So I know that y is negative 6. So I have my solution of negative 2, negative 6. I'm going to take this solution and plug it into these equations just to make sure that I did everything correctly and that I do have the correct answer. I'm going to start with that first equation, y equals 3x. We solved for y and got y was negative 6. We solved for x and got that x was negative 2. I'm trying to prove that the left side of the equation equals the right side of the equation. So I'm going to have negative 6 equals 3 times negative 2 is negative 6. Does negative 6 equal negative 6? Yes. So it works for this equation. Now let's check the bottom equation. That bottom equation is y equals negative 2x minus 10. We solved for y and got negative 6. We solved for x and got negative 3. Oops, sorry, not negative 3, negative 2. I got to use the order of operations. Negative 2 times negative 2 is positive 4. 4 minus 10 is negative 6. Does negative 6 equal negative 6? Yes. So we have done everything correctly, and these two lines will meet at the point negative 2, negative 6. If we look at the next example, here I have y equals 3x plus 2 and y equals 2x plus 1. I'm going to take what y equals in this equation and plug it in for y in this equation. So instead of y equals 2x plus 1, I'm going to have 3x plus 2 equals 2x plus 1. From here, I have x's on both sides of my equation, and I want to get them on the same side. So I'm going to choose to subtract 2x on both sides. 3x minus 2x is 1x. I'm going to bring down my 2, my equal sign, and the 1. I want to get x alone. X is being, we're adding 2 to x. So to undo addition, I'll do subtraction and get x equals negative 1. So I have the first part of my answer, x is negative 1. Now that I know what x equals, I can take that and plug it into either one of these two equations. It does not matter which one you pick. I'm going to pick this bottom one. And when I pick that bottom one, I'm going to have y equals 2x plus 1. So y equals 2. And then I'm going to multiply that 2 by negative 1 because that's what we got x to be. So from here, I'm going to have y equals 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. So my y is negative 1. Let me check my work. If I plug into that first equation, I'm going to have negative 1 equals 3 times negative 1 plus 2. Negative 1 equals negative 3 plus 2. Negative 3 plus 2 is negative 1. Does negative 1 equal negative 1? Yes. Now let me check my second equation. So I'm going to have negative 1 equals 2 times negative 1 plus 1. Negative 1 equals negative 2 plus 1. Negative 2 plus 1 is negative 1. Does negative 1 equal negative 1? Yes, it does. That means we've done everything correctly, and this is our solution. If we look at example 4, again, we want to check to make sure that we have at least y equals for one equation, and lucky for us, we have y equals for both. So I'm going to take what y equals in this equation and plug it in here. So I'm going to have 5x plus 9 is equal to 5x plus 9. Next, I notice that I have x's on both sides of my equal sign, so I want to get them on the same side. So I'm going to choose to subtract 5x on both sides. 5x minus 5x cancels. I'm going to bring down my 9. I'm going to bring down my equal sign. 5x minus 5x is 0, and I'm going to bring down my 9. Well, normally when we do this step, we still have an x remaining, right? On all the other examples, when we did this step, we still had a variable. When I look at example 4, my variable has gone away, and all I'm left with is 9 equals 9. It doesn't mean that you've done something wrong when this happens. What we need to do is figure out, is 9 equal 9 a true statement or a false statement? Well, does 9 equal 9? Yeah, that's a true statement. When you get a true statement, that means that you have the same line. When you have the same line, that means your answer is all real numbers because these two lines intersect at every single point. And so our answer is all real numbers. Now, if you notice in the beginning that these two equations were identical, you could have skipped this step. If you notice that these were the same exact line right from the beginning, you could say, oh, same line. That means my answer is all real numbers. So you can work smarter, not harder here. If you notice that they're the same, you can jump right to this solution. Let's look at our last example, example 5. Here, I notice that both of my equations are y equals, so that's good. So I can take what y equals in this equation and plug it in for y in the second equation. So I'm going to have x plus 5 equals x plus 3. From here, I notice that I have x's on both sides of my equation, and so I want to get them on the same side. So I'm going to subtract x on both sides. X minus x is 0. I'm going to bring down that 5 and the equal sign. X minus x is 0. I'm going to bring down the 3. Again, my variables went away. All I'm left with is this statement. I need to figure out if this statement is true or false. So looking at this statement, does 5 equal 3? No, this is a false statement. When we have a false statement, that means that we have parallel lines. If we have parallel lines, that means that our two equations never intersect. And so our answer is no solution. Now, if you noticed up here that your slopes are parallel, and that's easy to see here because both of these equations are in slope-intercept form, then you can just jump straight to this answer and say, oh, nope, both of these answers, or both these graphs have the same slope but different y-intercepts. I know that they're going to be parallel lines, and so I'm going to have no solution here.